and today we'll be talking about client libraries in Iroha. The current situation is that it's been a while since we talked about them, and we all know that there were so many changes made to them lately. So today we'll have some very nice presenters talking about what they do in client libraries, with client libraries. So we'll also have some of the people who actually make those libraries and people who used to make these libraries in the past. So here's the antitrust policy notice, which is essential for every meeting of Hyperledger Consortium. So please read it through so we could go on. Here are the libraries that we currently have. It's Iroha Java library, which is coming soon. I'll tell you a little bit later about when it's coming and why. Iroha test containers also coming soon, and Java and test containers developer is present here. So yeah, the next one is Android. It will hold a sample app with the Iroha Java dependency in the future. So basically, it will work with Java library. Then Python. We also have a developer for that library here today. iOS library and Iroha.net. That one is waiting for contributors. And if you would like to, any of you would like to contribute into this library, it will be great and very interesting. Please let us know. Okay, so now we're coming to our first speaker, Konstantin Munichev. He'll speak about SWIG libraries, why they happened to be, and why we decided not to use them.
Okay, thank you, Sarah. I hope you can see my screen. So, okay, I'm Konstantin, and we'll tell you a story about how our client libraries were developed in the history and what are their status now. I will tell it pretty briefly, and details will be provided by guys after me. So, where we start? First of all, we planned support of different languages for our client libraries quite a while ago, more than a year from current time, and we looked for different strategies to provide such support. And actually, we decided to use a special tool. Its name is SWIG. You can see its name here. So it's a special tool which allows you to provide bindings from native C++ code to in different languages. You can use different solutions for different languages, like use Python for Python or GNI for Java and so on. But SWIG is probably only solution if you want to have different languages just same time. So it looked like a very good solution because we only need to develop a single library, C++ library, and then write some SWIG code, and well, it looked like it should work fine, but I'll tell you the whole story. So, where we start? Client code, well, well, I should tell that all client libraries and Iroha use Protobuf in the backend. and all communications are provided in protobuf objects. So when we use SWIG, we have two different types of objects: native protobuf objects and intermediate SWIG objects. Well, and yes, SWIG interface is pretty useless as platform dependent. Well, it's pretty useless because library is platform dependent. And B also released that SWIG is not a production level tool. It works great for experiments, for prototypes, but not for really good quality code. So I just provide here some examples of dumb things what you should deal with if you're using SWIG. So first of all, SWIG doesn't support templates in C++ in a good way. You should instantiate all of them manually. So, well, it's an example of code, and you should do it every time. SWIG doesn't support many of modern C++ features. It supports all C++ pretty well, but for modern C++, you have a problem. And for modern, I mean everything started with 11. It's just an example. It does not work well for namespaces. You should, well, do such ugly renames every time because, well, we have different classes with same name, different namespace, but well, to work with them in SWIG, we should provide such names. And actually, many others problematic things be discovered too. Well, it was not too bad, but actually to be able to deal with SWIG and to, well, to have SWIG at least work, we created a separate C++ wrapper to our C++ shared model, which is our actual C++ native library, to make SWIG able to work. So, well, it was not, well, our mood was not really good after we released it. And, well, it was on the beginning. If all of them, I just mentioned, was all we had to do, well, I will be really happy now. So, well, actually, after that, everything worked pretty well, but only if you have a PC or Mac. But, well, sometimes you want something more. You want to have libraries for Android, for iOS, for browsers, and, well, that's where actually problems began to be really pretty nasty. So, well, for Android, well, you know, Android typically use ARM architecture and actually different versions of ARM, and sometimes x86 with actually also different variations. So, well, we released that to make our libraries work, we have to support versions for 5 different architectures. We have to do we have to do cross compilations with Android native development kit because our initial C++ library is a native one. So it was pretty hard work and pretty painful. For iOS, things were even more complicated because, for example, for Swift library, we first needed Objective-C library. Don't ask me why. It's really, well, it's it's not easy to answer, but for some reason, to make Swift library works, we had to do first Objective-C library works, and to make it works, well, you already probably got the idea. We should cross-compile our library to make it work. Okay, but well, for web it was maybe even worse, because JavaScript library was just broken, completely broken. It just didn't work. But we found a community fix from some guy from GitHub. Many thanks to him. Well, he provided a fix. It was unofficial, it was unmerged, and SWIG maintainers refused to merge it for several months. So, well, we had to use it just to make things work somehow. Well, it was not a good time at all. And well, after that, we realized that all of these things, they're pretty easy to break, because, well, cross-compilation is typically not a very stable thing. And so we had to add support of all these configurations in our continuous integration system. Actually, I guess we haven't finished with it completely. Android bindings worked, but I think iOS didn't. And well, we resulted that we actually need a pretty huge effort to make everything work. So it looks like we only support one single library, but actually, well, we need to deal with all of them, all of this. So it was our mood. And we actually decided to go to different solution. So our intention was that SWIG library was a mistake. So I can provide a pretty simple scheme of it. So first of all, we have a native binary. Then we have a SWIG C++ wrapper to make just SWIG works. Then we have a SWIG interface. And in theory, you can use this interface in your language like Java or Python, but actually it's not very good interface. So in practice, everybody just developed his own interface to make, well, things work good for languages, different languages. And we had to support like full level of abstractions. Just I mean Iroha team. And yes, this native code was pretty boilerplate every time. And well, so what we have now? Now we have different libraries for different languages. They are written by professionals in them, so they are definitely of better quality with SWIG generated libraries. And in future, we actually want to provide some formal specification for them and provide a formal verification if they are able to pass tests. But well, it's a future. But target libraries are almost ready, and I think guys after me will tell more about them. So we have 100% native libraries. Well, they can be developed in any way. They are compatible with Iroha. They have a great interface and everything fine. So thank you for your attention.